Okay, so guys, I hope you all can hear me perfectly, right? Just let me know in the chat. I think it will be better to not unmute yourself as of now. And once you have, like, let's say the doubt session, you all can let me know what your doubts are, and just let me know what's the issues you have. Okay, perfect, perfect. So let's wait for 2 more minutes and then we'll continue. Okay. And once again, guys, thanks a lot to all of you for all the support that you guys have given to me. It has been like I think 3 years now, and to be honest with you, I cannot believe that we have hit over 30,000 subscribers. So once again, thanks a lot, everyone. Let me check this. Okay, perfect. So let us start right now. Once again, just let me know, guys, if you're able to hear me and if you're able to see my screen properly. Perfect, perfect, perfect. Okay, really great. So, hey everyone, I hope you are doing good. In this small webinar, we are going to talk about server side request forgery as we have discussed through the Telegram channel, right? So, okay, thanks, Anmol. I'm glad. So, yeah, we'll be talking about server side request forgery. And let me just share with you what is the agenda for today. So it's going to be like at the beginning, it's going to be very simple. We're going to go with the basic introduction. Then we'll see that, through a simple demonstration, that how we can, find server side request forgery in the wild, like how we can do that, on real application, and how we can find basic simple server side request forgery. Okay. Once we are done with that, we'll see some of the common POC and common bypasses. Like I'll show you some POCs where I was able to find few of the, server-side request forgery vulnerabilities through bypassing few of them. Okay. And then this is the most interesting part. Like once we have familiarity with, SSRF, we'll see that how we can, chain multiple misconfiguration to get a very interesting server-side request forgery. This is something that I have recently discovered in one of the pen tests, and by far, like in this year 2025, this is my one of the most complicated vulnerability that I've found. And this was in one of the, very big bank in Europe. So, and they had like 5 6 pen tests already, and they were not expecting us to find any vulnerabilities at all, but we were able to find that, and this was really critical for them. So we'll go ahead with the basics, and at the end, as always, we'll try to see through a practical demonstration that how we can go beyond, the basic things and reach to the advanced levels. Okay. So first of all, before diving deep into this, can you guys let me know through chats that what exactly is a server-side request forgery vulnerability? Like, what do you know about SSRF? You can just let me know, like, with whatever you know about it. No need to like give a very formal definition. Just let me know what you think about SSRF, and we'll try to keep interacting, guys, so that we can make this a little fun for me and fun for you as well. Okay. So yeah, can anyone let me know what is this SSRF uh, vulnerability? Okay, making request behalf of the other host. Yeah, this session will be recorded and it will be uploaded on YouTube. Okay, so no need to worry about it. The attacker forced the server making requests to different servers. Correct. Web server doesn't directly talk with us, but by SSRF it does. Great. Forward requests on behalf of the server side and access internal information. Okay, perfect, perfect. By the way, guys, just to know, How many of you are completely beginner in bug bounty, or you guys don't even know about what SSRF? Can you just let me know so that we can try to keep the webinar according to that? Okay, perfect, perfect. Just give me a second. Okay, so quite beginners are with us too, right? Okay, perfect. No issues at all. We'll start with the very, very basics. Okay, so let me just show you by a live example. Like, have you, like, do you guys ever seen a website like, let us say, Instagram downloader or YouTube downloader or something like that? Anyone? Have you ever used these kind of website, like for downloading videos, something like that? Maybe it's your favorite reel or something like that. Yeah, exactly. So what it is doing behind the scene, like, let me just show it to you with a simple example. Let's go to incognito tab and let's say Instagram downloader. Okay, sorry, Instagram reels downloader. Okay, we have one of this website, and let's try to understand what it is doing. Okay, just a second, I think. Yeah. So if we are going to paste a video of any Instagram reel onto this application, what is going to happen? Can anyone tell me what exactly is going to happen? Like, just let me know. I'm not asking for any technical terms. Just what do you think is going to happen? Anyone? If I, like, let's say, paste an Instagram reel and I click on download button, what's going to happen? A very simple answer is that it will get downloaded, right? As simple as that. But if we go into the technicalities, like what exactly is
Fetch
happening behind the backend?
fetch the content from external resource.
Perfect. Exactly. Exactly. Thanks a lot, Vikas. But I will request you to not unmute yourself for now, okay? Because it might, interrupt the session. But after this session ends, we can have a doubt session, and you all can just let us know, okay? For now, if you want to answer, just let me know through the chat, okay? Thanks a lot. So yeah, so as Vikas said, what's going to happen is that when you're going to paste a reel and click on download, behind the scene, the server is going to send a request to that reel, right? It will send a request to that reel, it will download the file, and then it will show it back to you with the download button, something like this, that download this video, something like this. And when you click on this, the video is going to be downloaded from the fastvideosave.net server, right? So what it is doing is that it is, whatever the user is giving input in this input field, is going to send a request to that, it's going to download this onto their server, and then it's going to, like, show it to you through this download button. And obviously you can click on this download button and the video will get downloaded, right? I hope you guys are able to understand this so far. Does anyone have any doubts? No, right? Yeah. So technically, what this application is doing, that it is sending requests on behalf of the user, right? Like whatever website I'm going to, but this application is supposed to, download Instagram reels. But whatever reel that I'm going to give to this request, give to this input, is going to send a request to that reel. It's going to download it onto the server, and we can save it later on. What actually happens is, in server side request forgery, that instead of the intended use, like for example here, the application is supposed to only download Instagram reels, right? But if we somehow trick this application into sending an internal request, or maybe a request to our server, this is what you call a server side request forgery. For example, again, let me tell you that in this application, it is supposed to only download reels from Instagram.com. But somehow, if you're able to send a request to the internal network, right, with this application, then it will be known as server-side request forgery. Not even that, if we can somehow, make it send a request to our server, then it will be also called a server-side request forgery. So basically, if, like, server-side request forgery is a vulnerability where the server is going to send requests on behalf of the attacker, right? And this can be very critical because, for example, let us say that there is, some file which is saved onto the server which is very sensitive, right? And you can only access it from your local machine, or from localhost or locally. If we are able to trick the server into believing that, uh, believing to that they need to send an internal request, in that case we might be able to fetch that sensitive file. I know it can sound a bit tricky for those who are a beginner, but definitely we are going to see this exact thing through a practical demonstration, and we'll be able to understand that, okay, how these things are happening, and how we can exploit this. Okay, but for now, this is what you call a server side request forgery. I hope you guys have understood this. Does anyone have any doubts? Anyone? Where were the beginners? Yeah. Jainit, Harsha, Lokesh, Ram. Anyone have any doubts? If you have any doubts, just let me know, okay? It's not going to be any issue at all. Okay, great, great. So this is what you call a server-side request forgery. Basically, it's a vulnerability that allows an attacker to send request to any other, server or their internal server by tricking the actual application. Okay, it's as simple as that. That's it. If anyone has joined late, no worries. They can check the YouTube video and they'll be able to understand everything from scratch. Okay. So this is what server side request forgery is. Okay. Great. Now, this was a basic introduction. Now let's talk about how we can find server-side request forgery in the wild. I'm not going to cover this into too much of detail because, to be honest with you, what I'm mainly interested in this advanced SSRF practical demonstration. Okay, these are the things that is already there on my YouTube channel, so you guys can always check it out. But we'll have a brief demonstration of it. So there are two ways of finding SSRF vulnerabilities. First is this manual exploitation, okay, which we're going to see, and the second one is automated exploitation, okay, in which we're going to use a tool which is known as SSRFmap. So let us quickly go ahead and try to see manual exploitation through a simple lab so that we'll be able to understand this in depth. Okay, so just let me do this one thing. Here we are, and just go back, and let me just go to the simple server-side request forgery lab, and let us try to read the source code of this particular application first so that we can understand this. Okay, so if you take a closer look here, this is a code in which there is like two routes. Okay, one is this fetch and one is this internal slash secret. Okay, now if you take a closer look, what it says that this is a secret internal point. You should not be able to access this because obviously this is intended for only access through internal uh, a request, right? If someone is trying to access this externally, it's not going to work. Okay, and over here you can see that there's this fetch endpoint which will fetch all the what you can say response body from the URL. Okay, let's try to go ahead and see it in action so that we can understand this in little depth. Clear this out. Node index.
Vyas,
Yes.
can you please zoom it?
Zoom in. I don't think we have this. Let me see if we can maximize the size of it somehow. Let me see. Yeah, increase terminal font size. Okay. Plus, yeah, I hope you guys can see it better now, right? Are you guys able to see this?
Yes.
Okay, perfect, perfect. Yeah, so let me just start the server. Okay, my bad. Just a second. Okay. Yeah, close it out. Start it again. And just one more thing. Yes. Okay, let's try to go ahead and access this server here, and let's go to fetch. This is the endpoint. It says that misses URL parameter. We'll just try to feed it a URL parameter here. Okay, and let's say the website is, you know, bing.com, just for this example. Let's try to see what exactly is happening in this case. When we are fetching, or when we are giving the input in this parameter, the application is sending the request to this, sorry, to this particular URL. Then it is saving the response and sending it back to us, right? It is as simple as that. This is what exactly is happening in this scenario, right? Now this application is actually, intentionally made this particular functionality where you can, fetch the URL contents. Okay, what can actually go wrong is that instead of sending an external request, if we are able to send an internal request, for example, HTTP localhost, HTTP 127.0.0.1. Do you guys know what exactly these terms are, like localhost or 127.0.0.1? Anyone? Just let me know through the chat. Yeah, what exactly is it? Can you tell me? Yeah, this is our local server's address, correct? Yes, home address, right? Yeah, exactly. So if we are able to trick the server into sending an internal request, we will be able to access some contents which are only supposed to be accessed, locally, or just to our machine or the local machine, right? So simply what we can do here is, let me just go ahead over here. Practical labs symbols. Yeah, this one. Like for example, you see this internal endpoint is actually supposed to be accessed locally. It's not configured in the code directly, but assume that it is supposed to be accessible only through, a local host. In that case, what we can simply do is we can simply go ahead over here and we can do something like this: HTTP localhost. Okay, and the endpoint which is supposed to be accessible only through internal means, right? As simple as that. We can just hit enter now, and you see the server actually sent the request to the local host, right? So if we go ahead and let me show you guys a diagram so that we can have a better understanding of it. Yeah, so let's try to understand what exactly happened. I hope you guys can see the picture clearly, right? So basically, what we tried to did is that instead of sending an external request to any external website, bing.com, google.com, drive.google.com, youtube.com, we sent an internal request. Whenever we are typing localhost or 127.0.1, something like that, what exactly is happening is that the request is getting sent to the server's local address, And now, if the application is giving us the response back, which means that we can sometimes, or most of the cases, we can access internal files or the files that are supposed to be strictly, not allowed to be accessible by public users. Okay, which is what we did over here. This internal endpoint, let me go back. Yeah, this internal endpoint was only supposed to be accessed by the server. What I mean by this is that you need to, access the server, and then you need to send a request, and then only then you will be able to access this internal content. But over here, we are still able to access it by tricking the server into sending the request to localhost, right? Similarly, we can just, instead of localhost, we can just do 127.0.0.1, which is something also points to the loopback address or the localhost, right? Again, we have gotten the same result, right? So this is a very simple demonstration of what server-side request forgery is. It's as simple as that. We are able to trick the server into sending the request, internal request, that is supposed to be accessible, only through that particular server or through the internal network. Okay, Does anyone have any doubts? Anything like that? Any doubts? Anyone? Yeah, it will be uploaded on YouTube, so no worries at all. Okay, what about our beginners, those who are new to bug bounty, like Harsha, Lokesh? Guys, have any doubts? Okay, perfect, perfect. Yeah, we'll talk about this, Naveen. No worries about that. We'll talk about it. Just a simple demonstration. Okay, we'll talk about the exploit. We'll see a practical example of the exploit. Okay, and it's going to be interesting. Okay, perfect. So let us do one thing now that we have understood this. Now, apparently, there's another tool that you can use to exploit server side request forgery, which is known as SSRFmap. If you go to Google, uh, just like this, go to SSRFmap, GitHub, and you can click on this very first link. Okay, so this is an interesting tool. This can be used to not only discover SSRF, but also exploit SSRF vulnerabilities. Okay, like you can use SSRF to a lot of RCEs, maybe get access to the internal MySQL. You can read files, right? And I have already created a video on this on my YouTube channel, where I have shown through a practical or a real website that how we can use this and exploit this. Okay, let me do one thing. youtube.com. Let's go to be practical. Yeah. And if we go here, scroll down, you can see this one. SSRF. Yeah, this one. This is the one that I'm talking about. Let me show you this. Just mute it out. I think this was the yeah. You see, this is the tool. This is how you need to actually install the tool. I'm just quickly going over it so that we don't spend too much time onto it. Since this video is available, I'll just give the link in the chat and you guys can access it. Okay, so you see, this is the module. This is how you're going to use the tool, the parameter, the vulnerable parameter, and the modules. Okay, we are simply going to just, for an example, yeah. So this is how we are going to use the tool. Okay, we need to copy the request body from burp suite. So as you can see, what I did over here is somewhere right over here. Second. Yeah, this is the request, right? You just need to copy the request body and then save it as, let's say, req.txt or something like that. Okay, and once you have that, what you simply need to do is you just need to execute the command as I'm showing here. You see ssrfmap.py, the vulnerable the request body with -r, the module, what you want to do. For example, I want to read the internal files. Okay, and let's go here, the vulnerable parameter, which was over here, pdf_path, and just hit enter like this. Let's go. And now it's going to try to read all the possible files onto the server. Okay, like it was able to read /etc/password. It was able to read internal source code of the application, you see, and it did a lot of cool stuff. So it is a great tool. If you are interested, just go ahead and download SSRFmap. And once you have found SSRF vulnerability, you can just feed it over here as given in the video, and then you'll be able to exploit this without any issues. Okay, like we're able to get the etc/host, etc/password right over here. I think this is etc/password, right? And all the other internal files which are very, very sensitive. Okay, and this is exactly how you need to find it. So I'm going to just copy the link and drop it in the chats. Yeah, Lakshmi, no need to worry about it. Okay, you'll get the YouTube channel, the video on the YouTube channel. Okay, I think it depends.
Hello, sir.
Yeah, Vaibhav, please go on.
Sir, I want to ask, like, will there be recording available on YouTube?
Yeah, it will be uploaded on YouTube. So no worries on that.
This session.
Yeah, this session.
Okay,
Yeah.
okay, sir. Thank you.
No worries. Okay. Any other doubts? The method is similar. You're talking about GraphQL request, right? I think this tool might not work in GraphQL, but if you're able to understand the video by the end of this webinar, you'll be able to understand that, okay, even if the tools are not working, you'll still be able to do the manual exploitation. Okay. I'm, to be honest with you, not a big fan of automated exploitation, to be honest. It's just great. If it works, it's great. Otherwise, always stick to the manual exploitation for as long as possible. Okay. But yeah, you can always give it a try. Okay. So yeah, this is exactly how you need to use SSRFmap. Okay. Does anyone have any doubts? Anyone? Yes, we can exploit SSRF manually. Yeah, we'll see that. Okay. Okay, perfect. So this is exactly how you need to find SSRF in the wild. I've just shown you a simple lab demonstration that works for a very vulnerable application. And SSRF map, you're going to use SSRF map once you have you have identified that, okay, there seems to be a possibility of SSRF, and maybe we can find something over there. Okay, this is how you're going to use it. Now let us talk about some common SSRF bypasses. Like if the application is secured, then how we are going to bypass that particular application, and how we can exploit this. Okay, for that I'm going to show you directly some of the videos from my PoCs which I have found. Okay, let me just do one thing. Yeah. Okay, let's go to SSRF POC and let's try to check all the POC one by one, and I'll try to show you guys that how exactly you can find this as well. Okay, so let's open one of them. Maximize this. Okay, so you see this is an application, okay, which was allowing me, and this is actually a private program on HackerOne. Okay, so this application allowed me to fetch feeds from any external resources. Okay, let me just show it to you. So you can like create a new feed. Okay, and you can just feed the URL, like any URL which you want to, from where you want to fetch the feeds. Okay, and it's going to send a request to that and save it onto your machine. Okay, it's as simple as that. So if you go ahead and play this, what I'm going to do is that instead of localhost, I'm going to type 169.254.169.254. Why is that? Because in cloud application, like suppose your application is hosted on AWS. You guys know what AWS is, right? Google Clouds, AWS. Yeah, exactly. So if the application is hosted on Google Clouds or AWS, so there is one more way to send an internal request. Okay, you can use Vapalizer, or you can use any other tool like WhatWeb, or even let's say that you don't know on which application or on which technology the application is hosted. Just give it a shot. Since we are doing black box testing, so it's worth giving it a shot. Okay, so yeah, let's go back. So what I was saying is that there is another way to send an internal request on, instead of localhost or instead of 127.0.0.1. Okay, which is this particular IP address 169.254.169.254. This is by nature is going to resolve to local host. Okay, if the application is hosted on Google Clouds or AWS. Okay, I'm not sure about Azure or anything like that, but I have seen this vulnerability many times on Google Clouds as well as AWS instance. To be honest, I've seen this a lot on AWS instances. So let's go ahead and see what is going to happen. So what I simply did is I just typed the URL 169.254. And why I typed this, because they blocked all the other ways through which you can send a request to internal localhost or to the loopback address. For example, if you could have typed 127.0.0.1, which we did in the first demonstration, it was not working. Local host was not working, and all the other tricks and tweaks that we have was not working at all. So this was the last resort that I had at that time. So when you see what happens, that when I clicked on next, it says that save feed, new feed, right? And simply will do, go ahead and click on the save button, I think. Yeah. Or if you take a closer look, we didn't even need to click on the save button, because once we clicked on next, what happened is that it was able to send the request to the local host, and this returned this particular uh, directory, which was only accessible through the internal local host, right, which is compute metadata. If you are familiar with AWS and Google Clouds, you know that how these things are working, right? Let's click on play. This is the directory which is only supposed to be accessed internally. There is no way that you'll be able to access this externally unless there is a SSRF vulnerability. So that itself tells a lot about the nature of the application and the vulnerability. Okay, let's see what happens next. You see it's working. I'm going to just click on download, run now, and then download. So it will show us the response. You see, I was able to fetch the internal directory or internal content of this particular application. Okay, you see, I'll try to go inside that directory, which is compute metadata. And as you can see, now we are inside the compute metadata directory. Then we've got another directory, which is V1, okay, which confirms that we are able to send the internal request, right? And this is how I was able to bypass one of the most common SSRF mitigation, and I was able to traverse into the internal directories. This was as simple as that. Do you guys have any doubts in this? Anyone? Okay, perfect. Okay, so let's go back and let's check out another one. Okay, so this was one of the way of how you can bypass this SSRF issue. Yeah, you will get this. You will get this recording. Okay. SSRFmap, I believe, is not going to work on this application. Why is that? Because when I entered, I have not shown you the actual request and response, right? So it was mainly a JSON data, right? And to be honest, I have not seen SSRFmap working very good on, you know, JSON bodies, but it will work if it's a normal request body like the one we saw in the video. Okay. Yeah. Let's go ahead and see another bypass. Perfect. SSRF bypass 2. Okay, this is an interesting bypass. Okay, this one is very interesting, and if you're able to understand this, you'll be able to understand the final thing that we're going to do. Okay, so please make sure to see this with full attention. Okay. So over here, I have created a program, okay, a simple web application. And once again, this is why I always tell people that if you want to go into bug bounties, if you want to, create your own methodology or you create your own ways of, building an exploit or something like that, you should know basics of web application development. Okay, you should know. I'm not saying that you should be a master in development. You should know basics. You should know that how post requests work, how get request works, what is routes, what is session authentication, authorization, and all those things. And this is, once again, I will recommend all of you guys that if you want to get into bug bounties, first learn the basic of web application development. you know don't need to go too much into it. Just learn how sessions are assigned, like what exactly happens in the backend when you perform an authentication, something like that. Okay, it will help you a lot. Trust me, it will help you a lot. Like, for example, if you are creating an application in Node.js, so you will be able to understand that, okay, if your target is developed on Node.js and Express, what can be the common vulnerabilities over here? What should I exactly look for? Okay, so this is exactly what you need to do. But yeah, apart from that, let's go ahead and see what is this code is all about. So basically, this is an application that if you're going to send a request to this application, it's going to redirect you to HTTP metadata. And again, if the application is hosted on Google Clouds or AWS, this metadata is going to resolve to localhost, which is 127.0.0.1. Okay, so what I'm simply doing is that I'm creating an application which is going to redirect us to metadata. Okay, and to be honest, this was the same issue, like the previous issue. They were able to fix that particular issue, and then I created another report where I was able to bypass their mitigation. So this is how exactly I did that. So let's see. It's going to redirect to metadata, which points to localhost again, and this is my IP address. So I'm just going to start the application. Okay, the application is started already. Yeah, the application started, and we'll go back to the application with the IP address of our server. I'm going to feed my IP address. So the server will think that, okay, this IP address does not seems to be harmful, because this is an external IP address, right, which is pointing to my server, not their internal server. But when you're going to visit that server, it is going to redirect you back to your internal network or the internal server. This is what they were unaware about. Okay, so just see what I'm going to do. I'm just going to click on next. Okay, and if you go here, you see that again I was able to fetch the internal data, right? It was as simple as that. Now this again requires you to have a little understanding of your application and how it is working, so that you'll be able to do this. Yeah, this is what you call a DNS rebinding attack. Not exactly a DNS rebinding. It's more of a redirection kind of attack, because in rebinding we like do back and forth on what you can say, like what it is called, what's the term, like initially we point to a different website, and then we point to the same domain is going to point to the internal network. That's what happened in rebinding. It's more of a redirection. Okay, and this is how I was able to bypass their restriction once again. Okay, do you guys have any doubts in this one? Yeah, anyone having any doubts? Perfect. Just let me know if you guys have any doubts at all, and we'll see how we can fix that. Okay, yes, exactly, this is the bypass of the older one where they fixed that, and I was able to bypass it once again. Okay, and let me show you the final bypass which I did on a different target. Okay, actually, to be honest with you, I have like 10-20 bypasses of SSRF which I was able to find on live target, but I cannot show you all of them because of the what's known as NDA, non-disclosure agreement. Okay, but yeah, let's try to go ahead and see this one. So in this application, it was something really interesting. Okay, let's see this. So we can actually upload our resume from external website. For example, you see it is uploading the resume from Dropbox. And obviously what this application was doing is that it was, how you can say, it was sending a request to the external services, which is over here is, yeah, I've got 2 bounties of that. Yeah. which is you know Dropbox, right? And then it was saving the resume onto their application, something like that. Okay, let's see this in action. Okay, you see, this is the file location, right? And it is pointing to the external directory. Sorry, external application. Okay, Dropbox user content. Let's see what is actually going to happen. Send this to repeater. $200. Okay. Let me. Yeah. So you see, what I'm trying to do over here is that initially the application, the host name was Dropbox user content. So this particular application was not accepting any other external domains apart from Dropbox user content. Okay. And you see what happens. If I'm trying to go attacker.com, go with attacker.com, you see, we'll get an error, which is status is failure, unable to send the request. So in the backend, they were checking whether this particular host name belongs to Dropbox user content or not. If yes, then send the request. Otherwise, don't send it. Play the request again. So what I basically did is I bought a domain with test-dropboxusercontent.com. If you take a closer look, this domain is exactly what the application was looking for. Okay, so I bought this domain. And then I have pointed that domain to my own host server, which I have for where I have hosted the application, the server. So see what I'm going to do is I'm just replacing this with bad dot test dropbox usercontent.com. Send a request. It says file is corrupted or conversion error. But if you take a closer look, it didn't say that it was unable to send the request to the server, something like that. It's a different error, which means something might have happened in the backend. And if you go to our server, you see we have successfully got a hit on our request, sorry, on our server, right? So now in this vulnerability, in this particular SSRF vulnerability, this was pretty much it. Okay, because we cannot traverse into the internal directory. But this can be an interesting scenario. Why is that? In cases where your application is using, let's say, Cloudflare or Akamai or CDN applications like that, this will help you to get the origin IP address of the server. Okay, which I mean is that the actual IP address of the server. Now, if the application is behind Cloudflare and if you're able to get the origin IP, it can be considered as a vulnerability by some of the bug bounty programs. Not everyone will mark it as a vulnerability, but some will do this. For example, in my case, I was able to make them understand that, okay, I was able to get your origin IP address, and this IP address is something that shouldn't be accessible or shouldn't be viewed by the public user, right? Because maybe there is something else that is restricted, but I can access through this origin IP address. It can be sensitive thing. So they understood that, and they actually, mark this report as triaged. Okay, it's as simple as that. So what I simply did is, if you take a closer look from here, application was only allowing us to send a request to Dropbox user content, but I was able to trick the application into believing that I'm still sending a request to Dropbox user content, but actually it was my own controlled website. Just go here, which was test-dropboxusercontent.com. Okay, you guys have any doubts in this? Anyone? No, you need to actually see, this is the reason why I bought this domain. Okay, because I wanted to show them the actual impact. You need to, like, if you are really sure about the vulnerability, you need to show it. This is what you need to do with bug bounty programs. Okay, they're not going to say that, okay, they're not going to accept any theoretical scenarios. You need to show them the actual impact. Fine. Okay. Yeah, I actually removed the cookies because I also wanted to show them that, even if the user is not authenticated, they can still send the request to this particular application, which actually increases the severity of this issue. Because now that any non-authenticated user can do it, then it will be a slightly more issue for them. Okay, you guys have any doubts? Anyone? Any doubts, anyone? Okay, perfect. Perfect. So yeah, this is exactly just yeah. So this is exactly how you can bypass server side some of the common SSRF protection. Okay, there are actually some resources that I would like to share with you all. Let me go back here. This two resources are one of my favorites. Okay, I always use them whenever I'm doing bug bounties or something like that. Let me just show it to you. Okay, so this can help you to understand what are the payloads that you can use to exploit SSRF. What can be done over here? Like you see some of the common bypasses. It will also show you that. Okay, like you see the DNS rebinding issue. Okay, SOP bypass and all those things. So whenever you're going for SSRF, just try to check these resources, and this will help you to understand or maybe find some more interesting vulnerabilities. Okay, if your application is hosted on Google Clouds or AWS, you can check this resource. Okay, this will, like over here you see, this is how I was able to get this IP address 169.254.169.254. So it will tell you that, okay, what exactly can you use in cases where your application is hosted on AWS or Google Clouds, and you want and the local host is blocked. So what can you do in that case and in that scenario? So you see, you can actually like you see, for example, if it is hosted on Google Cloud, you can use metadata.google.internal. This is exactly what I have used in the second bypass, if you remember, right? So yeah, this is how you can go for these SSRF vulnerabilities. Okay, so I'll drop this in the chat as well so that you guys can have a look at it. What can be the issue? What issue can be exploited with IP alone? The IP can be, as I've told you, I'm not sure that every program is going to accept this, but some programs will accept this if you make them understand that your application was behind Cloudflare, which means that your origin IP address should not be disclosed to the public user. But here I was able to get the public IP, your origin IP of your server, right? And in many cases, like there was a scenario where I was able to access some internal files which was not supposed to be accessible when I was using the Cloudflare's IP address. So if you can make them understand like this, chances are that they'll mark your report as triaged. Okay, these are the issues. Like for example, you can do an nmap scan and you'll be able to get some hidden ports that are not accessible through the Cloudflare CDN alone. Okay, that actually depends on your target, to be honest with you. Okay, Antu, I hope you have understood this, and I hope I'm pronouncing your name right. Yeah, perfect. Okay, any other doubts? Anyone? Okay, perfect. Okay, great. So now I think we have discussed all these important things. Now we are good to go with the practical demonstration of advanced SSRF. Okay, and this is by far one of the most interesting SSRF that I have ever discovered. Okay, so what I want you guys to do is that let me go to blind SSRF lab. Yep. Let me start this. Sorry. Server. Okay. Interesting. Let me start the server here. So I want you all to go to this website, okay? And try to see if you're able to exploit, or just do one thing. Try to understand the application and just let me know what you think of it, like what the application is doing, how the application is behaving, okay, and what can be done over here, like just from the best of your knowledge, okay? How many of you are doing it? Just let me know so that I can be sure that how many of you are doing. Guys, are you able to do this? Like it will be an application, something like this. How many of you are going to do that? Just let me know. Okay, perfect. So it's a simple application where you can just feed it an image URL and it's going to save it onto the server. As simple as that. And this vulnerability was found in one of the biggest banks in Europe. Okay, so it's definitely something. So if you're able to understand how the application is working, that's plenty. Okay, I just want you to just explain that how the application is working and whether you think there is a possible exploit of it or not. Okay, theoretically or practically. That's it. Let's wait for 5 minutes then. Right, 5 minutes sounds good. Yeah, just wait for 5 minutes and then we'll see that. Yeah, so guys, what do you think of it? Anyone? If you want, you can also unmute yourself. Yeah, it takes an image URL and process it on the backend to check it. Yeah, you're right. Like, let me just show it to you guys. Okay, just to the example. Let's go with this URL. Okay, and just to show you guys that I'm not doing anything fishy, this. How many of you know this person? Do you guys know this person? Anyone? Anyone into anime? Yeah, exactly. Yeah, so if you're going to click on this URL, you'll see the image of Mother Uchiha. Okay, let me paste it here. Okay, and what exactly is happening? It is very much similar to the application that I showed you in the beginning, which was Instagram Reels downloader. Okay, like it is, instead of Reels downloader, it is just an image downloader. Now, obviously, we don't need an image downloader, but just for the sake of this demo, let's say that we need an image downloader. So I can just paste it here, the URL of the image, click on fetch, and you see that image is saved as this name. Let's copy this and just paste it here. And yeah, the image is saved on the server, right? It's as simple as that. Okay. Any doubts at all so far? Okay. So do you guys think there will be a possibility of any SSRF vulnerability in scenarios like this? And if you think yes, then what can you do? Like, how will you look for SSRF vulnerability over here? Just let me know, anyone. Like, in application like this, what will be the first thing that you will try to do? Putting burp collab, okay? Anyone else? What else will you try on these applications? Let's say that we're not looking for SSRF. Let's try to think as it is a live target and you are supposed to find something. We should have to fetch what's going on back and first. Okay, check response. Redirection. Interesting.
We can save like image metadata, bub collab in image metadata, then we can like send this request.
Yeah, we can do that. Okay, great. Okay. In my case, what I will first do is I'll try to see how the application is handling the different file types. For example, over here it is supposed to save the image files. I'll try to see if we can upload a PHP file, for example, because we see that whatever value we're giving, it is getting saved on the server, right? I'll try to see if we can upload a PHP file or HTML file. If we're able to do that, let's say if we're able to upload HTML file, we can achieve cross-site scripting, right? Or if we're able to upload a PHP file, and if the application is developed on PHP, we can get a remote code execution, right? This is how we can initially look for things, correct? Any doubts in this? Okay, I'll take it as no. Then let's try to go ahead and see how the application is behaving. If we are, instead of a PNG file, let's try to go ahead and see how it's behaving if we're trying to upload a PHP file, for example, PHP. Okay, I've just changed the extension to see how the application is behaving. Okay, let's click on fetch, and immediately it says that only images are allowed, right? Okay, let's try to go ahead and see what will happen if we do the double encoding technique, like png.html. Let's say, again, only image URLs are allowed, right? Interesting. Let's try to see what will happen if we just give it a plain URL instead of any image URL. Like, I can simply just copy this. So right now I'm not testing for any vulnerabilities. I'm trying to understand the application. Okay, this is very important. You don't need to jump directly into a vulnerability. You first need to understand how the application is working in different scenarios, right? Only then you'll be able to create a proper exploit of it. So let's go and do this. And again, you see, it says that only image URLs are allowed. Okay. Now, the last thing which I'm going to do is I'm going to paste and I'm going to type any random value like this, and I'll just make it end as .png. And I'm going to see what exactly is going to happen in this scenario. So it says failed to fetch the image, right? Which means the server is actually sending the request to the URL. And first thing what it is doing is it is validating whether the URL is ending with any image extension or not, right? Second, it is checking whether the extension is belonging to an image file type or not. For example, .jpg, .jpg, .png, maybe GIF, right? .bmp and things like that, right? These are the things that we're able to conclude, right? Now let's go ahead and let us try to do this thing that we can just go ahead and type 127.0.0.1 and let's see how the application is behaving. Again, as we know, let's try to go with test.png, right? It says that the local URL is not allowed. Even if the local URL was allowed, we still won't be able to get anything. Why? Because the application is always expecting us to add an image file in the end. You know, like we cannot just do 127.0.0.1, right? We need to add an image file. So the least thing, like let's say, even if we're able to send the request to this particular application, the least thing which we can do is we can download the internal image files. Correct? Right? I hope you guys are able to understand what we are doing over here. Right? You guys have any doubts in this so far in the analysis of the application? No, right? Okay. Okay. Perfect. So we have noticed few things. First, we cannot use any internal URLs like 127.0.0.1, localhost, and things like that. Okay. Then the URL is supposed to be ending with a file extension, and the file extension should be strictly ending with an image file type like PNG, JPG, BMP, right? Now, ideally, if you look into this, the application seems very secure, right? Like even if you're able to send the request to 127.0.0.1, you won't be able to do anything because it is expecting the file extension, the image file. So basically, it's of no use. Even if you're able to send the local request, it's going to be a normal request, and we won't be able to get anything out of it, like anything sensitive, right? So I'm asking you guys, like, what do you guys think we should do in cases like this? Do you think we can do something? Do you guys have any ideas at all? You can just let me know. There are chances that I might be able to learn something new from you guys as well. So if you guys have anything to say, just let me know through the chat, or you can just unmute yourself. I would love to hear about your opinions. Anyone? What do you think? How we can possibly exploit this? Try adding localhost with the uploaded image. With the upload image, like localhost slash image.jpg, something like that. Okay, capture the request on burp. Okay, let's do that. First, let's capture the request on burp. Let me see if I have my burp open. No. Let me quickly open it, okay? Burp suit. Okay, 127.0.0.0.0.1. Okay, let's use that. Sorry. Firefox. On the intercept. Just turn on the intercept from here too, and you can fetch URL. Okay, so this is the request. Okay, let's send this to repeater, and it says only image URLs are allowed. So one of you is saying that use this. So let's go ahead and try this one. No, I don't have that. I don't. To be honest, I don't use cracked softwares anymore, especially on Burp, because they steal your data. Okay, so that can be a critical thing. Okay, let me. Yeah, this is what you're saying, Pawan. Send the request. Yeah, so again it says that only image URLs are allowed. Okay, no worries. Let's see. Try adding localhost with the upload image. Would you like to elaborate this, Naveen? We can check if we can bypass front end validation. Okay, so as you can see, this request has been intercepted. So uh, it's basically on the backend, right? Yeah. Yeah. Okay. Using other variations of localhost IP. Yeah, we can do that. We can maybe try like 169.254.169.254. But you guys are not understanding the point. Okay, like 169.254. It's not going to, the application is not going to accept URLs like this. It's going to accept all the URLs which are ending with an image file. So for example, let us say that you're able to even send a request to this, but you won't be able to do anything, because at then you need to add this value, which is the image file. So the least thing that you can do is you can get an image file, internal image file. That's of no use, to be honest, or maybe that can be marked as a low level vulnerability, right? And even if you see, it says that it is failed to fetch the image, right? How we can change the content type? Because if you take a closer look, the content type is getting assigned in the backend. The file is not getting uploaded through here, right? It is getting uploaded in the backend. We cannot control the backend on how it is uploading the file. We just know that here's the URL. We need to we need to send the URL over here, and in the backend it's going to be downloaded, right? So it is actually very interesting. If you take a closer look, it is validating the file type properly, and it is validating the local host, or what you can say, yeah, whether you are giving any internal host name or any internal IP, is validating all of these things. So it is quite well mitigated. The issue is, the only issue that it has is something that I have shown you in the POC, in the second POC, if you remember, where we're able to redirect the user, redirect the server onto localhost through our server. You guys remember that? Right? Like, I think you guys may have forgotten. So let me share it with you. You see, I think it was, yeah, this one. So if you take a closer look, this is what we might need to do in order to redirect the server, redirect the application to the local host, right? Now, the second thing is that we need to create an application where, regardless of any file type extension, it should redirect us to the local host. Okay, and let me show you how we can do that. So I have created a server, a sample server, just for this demonstration, and this is exactly what I have used. Okay, let me show you the code. And once again, you see, this is why I tell you guys that having basics knowledge of web application development is crucial. Okay, let me show you the server that I have created, which is in here, cat index.js. Okay, take a look at this code. What it says, that we can send request, a get request, to any other endpoint, any endpoint. Okay, and it's going to redirect us to localhost metadata. What does it means is that, let me just tweak it a bit so that we can understand this. Like, let's say, comment this out, and let's say if for any get request I want the user to see hello world. Okay, let's run this program, and it is running on port 81. Okay, let's go all the way here, and you see what will happen if we try to access the application now. C control V, port number 81. Let's send the request. You see, it is responding with hello world. It is giving us this response. What I'm going to do now is, I'm going to, let's say, type extension like this.png. Again, you see it is redirecting us, or it is giving us the response. So for any get request, I am sending the response that hello world. You guys can try it out for yourself. Okay, try it out with any other extension like HTML, MOV, PHP, or anything like that. Okay, it is always going to give you this response because this is what exactly this application is programmed for. Okay, as simple as that. So what I just can do here is that, let me just stop this for now and modify this a bit. So what I can do here is that I can, for every request, I want the application to be redirected to the local host, and this is the endpoint that I need to access. Okay, like this is the endpoint that I'm supposed to get access to just for the lab. Like if I go to and access the metadata, you see it will give us some error that only local host can access this endpoint, right? Okay, let me go back and let us go ahead and start the server. So what I'm going to do is for every request, I'm going to redirect it to the metadata. Okay, close this, start the server. It is saying up. Server is running fine. Let me see my lab is working fine or not. Yeah, it's working fine too. And here we are, right? You see, what I'm going to do now is I'm going to copy this, feed it here with port 81. Okay, and I'm going to type any random value. Okay, but I'll make sure that it's going to end with dot any image file. So I'm going to type, let's say Vikas dot png. Okay, and let's click on fetch. By the way, I hope the server is working fine, just in case. Just a second. Yeah, and let me see, it is okay. It's not working. It's just a second. Okay, my bad. Start this again. Okay, yeah, my bad. It's working fine. So redirecting us to localhost, and let's copy this. So, okay, seems like there's an issue. Let's do one thing. Let me stop this now. Index.js localhost metadata. Instead of that, let's leave it with hello world, and let's try to exploit it with this. Yeah, you might be correct that we might need to disable Foxy proxy for this. Let's go here and let's try to access cast.png. Interesting. I think okay. Check the source code. 81 nano index. Instead of 81, let's do this at 82. And yeah, everything seems fine. Node index.js up, and let's go here. And let me remove because let's do 82. Is this the correct IP address? Let me. Yeah, this seems correct. Okay. Okay. 105 point. Oh, okay, my bad, my bad. The IP address is correct. No, the IP address was wrong. Okay, and because.png. Yeah, it's working. Let's go ahead and paste it over here like this. Because.png, and let's click on fetch with fingers crossed. And you see what it says, that it was able to save the image as this PNG. Okay, let's try to access this. And you see, the moment I'm trying to access this, it is giving me the error because obviously the content inside the file is not an image file. So to actually verify that, let's go to our network tool and let's do a quick reload. Okay, says 304. Let's go to the response. Okay, so the main issue I was facing in that particular session was I was actually typing the IP address incorrectly. If you watch the session, you'll see that the IP address is ending with 213 and I was typing just 21 or something like that. Okay, so let's try to go ahead and reproduce that same issue. So you can see here we have the server running, right? And what I'm going to do is I'm simply redirecting any traffic that is coming into my server to the localhost slash metadata. And if you all remember, metadata is restricted to be accessed publicly, right? So let's go ahead and run this. And over here, what I'm going to do is let's check the IP address. Sorry, ifconfig, and copy the IP address here. Let us paste it here like this: http IP address and the port, which was 82, and we can type any image or any value ending with an image extension. So again, I'm going to go with vikas.png. Okay, and we can simply go ahead and click on this fetch button and let's see what happens. As you can see, it says that image has been successfully saved as this image, right? Let's copy this, and the first thing that I'm going to do is that I'm going to intercept this request from burp suite. So let's do this real quick. Let me just check my burp suite is working fine or not. Seems to be working. Let's hit enter. Yeah, we've got the request. Let's send it to repeater. And over here, what I'm going to do is I'm just going to replace this with the image that is saved, right? You can see that the image name was, if you go here, the image name was this. Okay, and this is exactly what we have written over here. So if you go ahead and click on send, you see that it says sensitive endpoint accessed successfully, right? Which means that you are successfully able to send an internal request to the endpoint which was supposed to be only accessible through localhost or to the server itself, right? But we were able to exploit the the server side request forgery, and we were able to fetch that particular value, right? Another thing that I would like to show you all is that if you copy the URL, okay, and if you paste it over here, notice that we won't be able to see anything because the browser is treating this file as an image file, and obviously the content inside this file is not an image. That's why it says that the file is corrupted or it contains error, right? So this is exactly how you can look for this kind of server side request forgery, vulnerability. The main issue here was that the application was expecting us to provide an endpoint that is always going to end with an image file type, right? So basically we created a server which allowed us to redirect any traffic, even if it is ending with .png, .php, or .html or anything like that, to the local host, which eventually allowed us to access the internal endpoints, right? I hope you guys are able to understand this. If you have any doubts, just feel free to let me know in the comment section. And once again, guys, thank you all for all your supports and you know helping us to reach 30,000 subscribers. And I hope you guys will keep I hope you guys will keep supporting us and helping us to grow further. So, yeah, with that being said, keep learning, keep hacking, and thank you so much for watching this webinar.